What an arithmetic sequence is a sequence in which there is what's called a common difference from one term to the next. What that means is that you're adding the same number to a term to move forward. When I talk about moving forward, I'm talking about moving left to right in the sequence, from the first to the second or the third to the fourth position, etc. The common difference can also be found in a more analytical way rather than just looking at two terms and saying, what do I add to move forward? If you're not sure, you can take a term and subtract the term that's immediately before it. That will figure out what you're adding to move forward. However, I want to introduce something that we didn't really talk about specifically yesterday, and that's this notation. I can say that the common difference is T2 minus T1. And what that means is I take the value of the second term minus the value of the first term. That's D. I could say that D is T3 minus T2. And I'm asking you to think about that and what that means. It means I'm taking the third term and I'm subtracting the second term. And this is not difficult, but it's graduating towards something that will be a little bit weird to think about in a second. I could take T4 minus T3. That would give me the common difference. I could take T5 minus T4. And I don't have to proceed in this fashion of going 2 minus 1, 3 minus 2. I can do that. And if I tell you the 174th term of a sequence, and I tell you the 173rd term of the sequence, you ought to be able to determine what the difference between those two terms is. And if it's arithmetic, it's the common difference. Now things are going to get a little bit messy to think about. In general, I can say this. Roll that around in your head. Tn minus T sub n minus 1. All this is saying is I take a term and I subtract the term immediately before it. I could, and you may see this in this course or in later courses, I could say this. I could say the n plus 1th term minus the nth term is going to give you the common difference. The key idea here is that in all of these, what do I have? 7 different statements up here. The term number to begin with, for example, T3 minus T2, the term number is 3 minus the term number T2, which has a term number of 2. It's 1 less. So if I take the nth term, I have to subtract the n minus 1th term, because n minus 1 is 1 less than n. If I take the n plus 1th term, I have to subtract the nth term, because n is 1 less than n plus 1. And this is what I mean as an example of what I was talking about yesterday, that this course becomes more abstract, less concrete, less practical, less I can hold it in my hands and look at it, and more I have to think about this. That being said, does anybody have any questions you would like me to go over from any of these? I know that some of you had some questions you weren't sure of. Emmanuel, did you have one? What was it? 5b, certainly. So negative 14 is which term of this sequence? Now we are going to learn a different way to do this today. And we're going to develop a formula based on what we know. But I think it's useful to write out the sequence kind of just spread out a bit. And it's 2 1/5. And I'll tell you right now, of all of the ways you can write numbers, the most useless way is a mixed fraction. It's a horrible thing to look at, because you might even confuse this thing with meaning 2 multiplied by 1/5, which technically it does, because when we write things beside each other, it means multiply. But this is a very archaic, elementary, junior high-ish way of writing things. the first thing we want to do is put that into some sensible form. And I'm just going to write 2.2 because I happen to know that 1 over 5 is 0.2. Okay. Now, if I don't, say I'm having a bad day, something's on my mind, one of those things that just is bothering me and I can't get rid of it, I can go on. I don't even want to think about it. 1 over 5 is 0.2. Add it to the 2, 2.2. Alternatively, rather than writing 2.2, if you're going to write it as a fraction, 11/5 is the way to go. And what I'm doing there, and this has nothing to do with this lesson, I'm just talking numbers and basic math. What I'm doing there is I'm saying I have 2 and I'm adding to it a fifth. I need a common denominator. I'm going to multiply the top and the bottom of this fraction by 5 to get 10/5 plus 1/5. And we did have a little bit of a conversation near the end of yesterday's class about thinking of that 10 over 5 as 10/5, not 10 divided by 5. Because then you can draw all kinds of analogies like, if I had 10 puppies plus 1 puppy, I have 11 puppies. If I have 10/5 plus 1/5, I have 11/5. Okay. So just to set the stage here for answering this question, I'm going to go with decimals. This becomes 2.0. I should be able to figure out what the third term in, you did say B, right? I should be able to figure out what the third term in B is because I'm told it's arithmetic somewhere. And I can see that I'm losing 0.2 here. So if I subtract another 0.2, I end up with 1.8. It's telling me, by the way, the common difference is negative 0.2. Because negative 0.2 is what I add to one term to move forward. Or if I take a term and subtract the one before it, I get negative 0.2. Are you fine with working in decimals in this question? Okay. And just to remind you what I said yesterday, there's nothing wrong with working in decimal form if the decimals are nice decimals. Not 0.358725553. Okay, but 0.2, 0.0, 0.8, those are okay. So what do we know? We know the common difference is 0.2, negative 0.2, and we know the first term is 2.2. And where I'm going to be going with this eventually, and starting right now, is these two numbers are the key to answering any questions about this sequence. If you know the first term and the common difference, you can find out anything. Unfortunately, you don't have a formula to do so. So one of the ways we can do this, there's a lot of ways, but one of the ways we could do this is we could just start taking 2.2, 2.0, 1.8, 1.6, and keep going until we got to negative 14. And I think maybe you understand why that's not really what we want to do. It's possible to do it that way, but it's going to take a long time. What we are going to do is say to ourselves that to go from the first term to that term, we have to add something, right? And what we have to add is a whole bunch of common differences. Okay. This is leading up to today's lesson actually, if I go from here to here, Emmanuel, it's Emmanuel, right? I have to add one common difference. If I go from here to here, I have to add two common differences. The point I'm trying to get across here is to get to any term, you're always adding a multiple of the common difference. Maybe you're adding 100 common differences, maybe you're adding 13 common differences. But what we are adding is a multiple, and I'm going to use the letter M, times the common difference. And the common difference is negative 0.2. I'm using M for a particular reason. I don't want to use N. And I think a couple of you, I see you understand why N is problematic here. And we can solve this. Let me clean this up a bit. This is a, I don't know, I'm going to write this as negative 0.2 m equals negative 14. This is, I don't know, a grade 6 equation, I think. Maybe grade 7, but it's something certainly that you should be able to solve. And I don't know if I've mentioned this to you, but I'm a huge fan in teaching students math of taking a problem that's at this level we're at right now and turning it into a problem that's at a simpler level. Just this morning in Math 30-1, we had a problem. And I used this analogy. We did one thing using our knowledge of 30-1, and it turned into a Math 20-1 problem. We did one more thing to that, and it turned into a grade 4 problem, literally. So you're always trying to make things simpler in terms of easier math. I mentioned yesterday, and I'll mention it again, my goal here is not just to teach you content, it's to teach you math. And I know you might say, what's the difference? What I'm about to explain to you is something that you use in all units. This is called a linear equation, and in order to solve a linear equation, you have to rearrange it for the variable, for the letter, okay? I do not like having a term with the unknown in it that's negative. I do not want to have negative 0.2m. So what I'm going to do is I'm going to add 0.2m to both sides, and that will move this to the other side where it becomes positive. And at this level, unless I'm doing a written response assignment or exam question, as a student, I'm not expected to write plus 0.2m plus 0.2m. It's okay in your day-to-day work to just say, I'm going to move it over. And by the way, then if I move this negative 14 over, it becomes positive. And everything I'm doing here is something that you should know how to do on your own, but I'm giving you my accoutrements to it, my additions to it, my thoughts on it. When I take 2.2 plus 14, I get 16.2. So I get 16.2 equals 0.2m. And I believe when I divide by 0.2, I get 81. Is that right? Okay. Now comes the difficult part. Conceptually difficult. Not difficult with a lot of math, but you have to sort something out in your head. And if we knew a formula, we could get the answer quicker. But if I go back and I talk about going from this 2.2 to the 2, I add one common difference. 1. But when I add one common difference, I get the second term. When I add 2 common differences, I get the third term. If I add 1, 2, 3 common differences, I get the fourth term. So if I'm adding 81 common differences to get to negative 14, negative 14 is the 82nd term. And that's the logical conclusion to this, which is a little bit complicated, but this negative 14 must be the 82nd term. Because, and really this is the big part of today's lesson, you add one fewer common differences to get to a particular place in the sequence. If you ever want to know how to get to the 12th term, you add 11 common differences. Because you don't count the first term. You're adding after that. Is that okay? Now, after we learn this formula today, I will show you, we'll go back to this and I'll show you that there's a less thoughtful way of doing it. There's a way to just say, I'm going to grab this formula, I'm going to use the formula properly. Other questions? Stretch. Oh. All right, let's move on. So we're going to be looking today at lesson 20.1.1, which is arithmetic sequences part 2. And you will need your note package open to I'm going to say page 3. Page 3. Thank you, Gustav. Is that how you pronounce your name, Gustav? Close enough. So here we go. This is what I was just referring to. There's a formula. It's called the general term formula. And it's going to be a formula that you do not have to memorize. It will be on a formula sheet that you get for all exams, including your final exam. And what we're going to be doing is solving some of the same problems we just talked about and solved yesterday using this formula. And we're also going to be applying our knowledge of arithmetic sequences to other situations that are new to you. Okay, so this is typical in high school math. We don't learn something and practice that same thing for 2-3 days. We practice that thing for a day, and then we practice that thing applied to more complicated situations for a day. Okay, that's what I meant by yesterday saying this course is like a race. Every day we're doing something different. And we're going to be looking at the graphs of arithmetic sequences because there's a feature of the graphs that's very important. To begin with, as a warm-up, and I've kind of alluded to this already yesterday and in our conversation here with Emmanuel this morning or this afternoon. Consider this sequence, 10, 16, 22, 28. With a little bit of thought, it should be pretty obvious that that is arithmetic. Can you just confirm, just run those numbers one by one through your head and confirm it's arithmetic? Nate, what is the common difference? 6. And the first term is 10. So 10 plus 6 is 16, plus another 6 is 22, etc. So question A says, what is added to the first term to find the second term? Well, 6, right? 6 is added to the first term to get the second term. What is added to the first term to get the third term? So, and I'm talking about a number here. What is added to 10, which is the first term, to get 22? 12. It's not a difficult problem. And it's not a Math 20 problem, right? This is not an exam question. This is a learning situation. What do I add to the first term? What do I add to 10 to get the fourth term? Well, that would be 18. But in a less practical view, what's important is adding 6 to the first term is the same as adding one common difference, because the common difference is 6. Adding 12 to the first term to get the third term is the same as adding 2 common differences, because the common difference is 6. 2 6s gives you 12. And adding 18 is the same as adding 3 common differences. And you know what? I suspect that before I gave you any things to put in the blanks, how many of you were thinking 1 common difference, 2 common differences, 3 common differences? You weren't even thinking of numbers, maybe. I think you know where this is going, but just to highlight it, I want to make sure that you understand that there's a discrepancy between the term number that we're talking about and how many common differences you're adding to get there. If you want to find term number 2, you add 1 common difference. If you want to find term number 3, you add 2. If you want to find term number 4, you add 3. We're back to what we just talked about, that you add 1 fewer common differences than the number for the term whose value you're trying to find. We can keep going with this, right? What do I add to the first term to get to the fifth? Well, at this point in time, I don't even really care what the fifth term is. It's easy enough to find. And I don't really even care what the number is. Apparently, the number is going to be 24. Does that make sense? That the next term, if I put another 6 on here, would be 34. 34. And to go from 10 to 34, you add 24. So we can put the 24 here, but quite frankly, that 24 is of little interest to me. What's of more interest to me is 4 common differences. What would I add to the first term to get the 23rd term? Well, listen, figuring out what this number is really unimportant, and it's a lot of work, isn't it? It's easier to say, Jay, how many? 22 common differences. And then, actually now knowing that the common difference is 6, it's pretty easy to figure out what the number is, isn't it? We can say, wow, I think it's 132. So, but again, this number here, I'm really not that interested in it. So now, to take a step away from the concrete and actual numbers, let's talk about something a little more abstract. What would I add to the first term to get the nth term? Any takers? Yeah. N minus 1 common differences. You're adding one fewer common differences than the number whose term you're trying to find. So you would add n minus 1 common differences. And we don't know what the nth term is, so I can't say whether we're adding 6 or 12 or 18 or 24. It's the nth term. It's any term. And this idea is very useful in solving problems like the one that we went over, question 5b, I think it was. However, it becomes even more useful if we can take this idea and build an equation out of it, a formula out of it. And that's what we are asked to do here. Use the answer to f to give us a formula that we can use to find any term in the sequence, Tn. And really, the nth term, we said, was found by adding to the first term this many common differences. And that's the formula. That's it. That's a formula that we could have used to solve the problem that Emmanuel asked about. But it's going to require some thought here, okay? First thing we want to do is we want to write that formula in that box. And then I'm going to add a couple of other ideas to this formula that I need you to pay attention to and possibly even write down. Owen, are you with us? Okay, so this has to be written in the box. I want to make a point here, and this is obvious, I know, but there's a bigger picture here that I need to teach to you, and it's something that we talked about just this morning in 30-1. It's that in equations, some of the things in equations are variables and some are not variables, okay? When I look at this formula, it is an equation. I have T1 and I have D, and they are what we call parameters. These two things are called parameters. And if we apply this equation to a sequence, those numbers, those parameters, have particular values for every term. And I'm stepping outside of the content of my lesson now to talk about math in general. So, for example, if I had 3, 5, 7, 9, etc., the first term is 3. The common difference is 2. And this is the important part about a parameter. If I use that formula to find the millionth term, I still use the first term is 3 and the common difference is 2. The first term is 3 and the common difference is 2 for any term that we find. What changes, though, are these two things. This and this, these are variables. For the first term, n has a particular number, 1, and Tn happens to be 3. If I make a table of values, we talked about this yesterday, but just mentally digest that table and what that table is telling you in relation to this sequence of numbers that I've given you. So what's happening to n? N is changing. It's variable. N depends on which term you're talking about. But even if I went down here and said, let's go all the way down to the 11th term, we can use this formula. I'll rewrite it here so we can see it. We can use this formula and say the 11th term will be the first term plus 10 common differences. We're adding one fewer common difference than 11. And I work this out and I get 3 plus 20. I think I get 23. Yeah? All right. But when I did this calculation, T1 was still 3. And the common difference was still 2. A parameter is a value in an equation that stays the same for every calculation. A variable is like your x and your y. They're numbers that change, but they're connected to each other. They're like ordered pairs. That is not crucial to being able to apply the math today, but at many opportunities I'm going to start talking about parameters and variables because it's helpful later on. All right, write the general term for each of the following arithmetic sequences. I don't know if you remember, but yesterday we had a sequence. I'll show it to you again. In one of our examples yesterday, we had this sequence here, -4, -1, 2, 5. Remember doing this? And I told you that this formula, T sub n equals 3n minus 7, could be used to calculate all of those terms. Remember us doing that? What this question is that you're looking at right now, example 1, is asking us to find what the general formula is. How can we find any term knowing n? Well, we make a list of our parameters. T1 is -6, and the common difference, I'll give you a minute, well, not a minute, I'll give you a few seconds to determine what the common difference is. Remember, it's the number that you add to a term to move forward, or it's a term minus the term before it, and no matter how you cut it, I get 4. Okay, so these are parameters. What's the formula we could use to find any term? Well, we take our formula off of the formula sheet, and we load into it the parameters that define this sequence. So I'm not going to put a number in for Tn because Tn is continually changing. It's variable. I am going to put in a value for T1 because we're told what T1 is. And again, at the risk of being overly repetitive, I don't care whether you use this formula to find the third or the millionth term. You're still going to use T1 equals -6. So we can put it in now. That's what it is. Plus n minus 1. We're just following this formula times the common difference, which is 2. And that is a formula. That is a general term. 4. Thank you. And I mentioned this yesterday. I do that frequently. Okay. If I make a mistake like that, feel free to let me know. I appreciate that. So that's a formula that we can use to find any term. But that is not how we want to express it. We want these formulas or these expressions to be written in simplified form. So the first thing I'm going to do is multiply that n minus 1 by the 4. And you don't normally see stuff written as n minus 1 times 4, but n minus 1 times 4 is the same thing as 4 times n minus 1. And we should know that when you multiply what's called a monomial, 4, by what's called a binomial, n minus 1, you have to use the distributive property. I have to multiply this 4 by the negative 1, and I have to multiply that 4 by the n. Notice I said by the negative 1. That minus in front of the 1, it's more useful to think of it as a negative that's owned by the 1. Don't think of it as minus 1. Think of it as n plus negative 1. So what do I get here? I have Tn equals negative 6 plus 4 times n is 4n plus 4 times negative 1 is negative 4. And now we have negative 6 and negative 4. I can add negative 6 and negative 4 together because they're the same kinds of things. They're numbers. So what I end up with is 4n, and negative 6 and negative 4 is negative 10. That's my general formula. You with me? Okay. Is there anything wrong with writing this? Absolutely not. Okay. I don't tend to write things that lead off with a negative. Okay, but this is so I think this is the best answer right here. Now, what else are we asked to do? Find the 40th term. Well, I want to show something to you, though. We'll do this first algebraically. So the 40th term means, what's that? That's what it's saying. And I would like everybody to get used to thinking of an equation like this as something where you put n in and the whole thing comes out. Be useful for later. So this is just a tool that we toss the value of n in. The formula calculates it. Well, we're going to have to calculate it. And then what comes out is Tn. So T sub n will equal 4 times 40 minus 10, which is 150. Okay. So the 40th term, and I really should write T40 here. The 40th term is 150. And I want to show you something. And anytime I show my Math 20 students or 30 students this kind of thing on the calculator, I have to preface it by saying, you're expected to be able to do this on paper. Okay? But grab your calculator. Whoops. Grab your calculator and go to y equals. If you have anything in there, clear it all out. We're not going to be graphing anything here. That's not the purpose of this. I'm going to put in here the general term expression, which was, help me out because I've cut it off, 4n minus 10. Okay, so I'm going to put 4n minus 10. I don't have an n key, so I use the x key. And then minus 10. Now, in Math 10C, how many of your teachers showed you how to use the table feature? Not too many. Okay, this is a brilliant feature of the calculator that's often overlooked. I'm going to go to my table setup, which is second window. And I'm going to start at x equals 1. I'm going to have my delta table, which means how much x is going to go up by every time. I'm going to set that at 1. And I want to set everything else on automatic. And I suspect if you've never used your tables before, that's what it says. Are you with me on that? Everybody's caught up here on your calculator? Okay, now go to the table. There's the sequence. My table does the calculation for all these different values of n. It's x, but it uses x equals 1, which is n equals 1, and it calculates the term as negative 6. This table, everybody, that we have generated, there we go. is basically this table. And this becomes useful because if you have multiple calculations to do, it's very easy to make a mistake, but here it's foolproof. And I can scroll down this table if I want. And I could scroll all the way to 40 if I wanted to. Or I could do this. Go back to your table setup, which is second window, scroll down, and where it says independent, and that means X, go to ask and hit enter. And now when you go to your table's not populated because it's waiting for you to enter a value of X. What's the 36th term? 134. Unfortunately, there's no way for you to enter a Y and get an X. Okay, it doesn't work that way. All right, let's move on. So we want to do the same thing here. Remember that the basic strategy is this. You need to put in the parameter T1 and the parameter, that's a D, and the parameter D. We need to put those numbers in, simplify the result. The first term is 1.75. The common difference is negative 0.25. Can everybody confirm that the common difference is negative 0.25? Okay, so we load those in. I get the general term Tn is 1.75 plus n minus 1. Listen very carefully. I mean, I've been doing this a long time, and I see and I remember things that students do that cause problems. Do not do that. Do that. It's multiplied by. Put it in brackets. You may say, oh, I know it's multiplied by it, and you're not going to put it in brackets, but it causes problems. If we want to do things, we need to do things right. So now I need to multiply this by the negative 1 and by the n. T sub n equals 1.75. When I multiply that negative number by n, I get negative 0.25n. When I multiply that negative number by negative 1, I get positive 0.25. And now I can take that 1.75 plus 0.25 and get T sub n equals 2 minus 0.25n. And if you wanted to, but I'm not going to, you could put that in for y1, set up your table to start at 1 and go up by 1 automatically, and you would confirm that you get these terms at the top of the screen. We do want to find the 40th term though, right? And listen, as much as the table thing is kind of interesting, to find the 40th term, it's just as easy to take 2 minus 0.25 times 40, right? You don't need to create a table. T40 I believe this is going to give me negative 8, but I would appreciate some confirmation. Okay, good. So that's one use for the general term. Let's take a look at the next page, please. Algebraically determine which term in the sequence has this value. This is the question that Emmanuel asked about. Different sequence. But the question was, which term, I think, was negative 14? This is saying which term is 220. Well, the key to solving this problem is creating a general term formula for this sequence. Okay? Let's not worry about solving the problem just yet. Let's simply worry about doing with this what we did with the previous question. Putting in D, putting in T1, and getting an equation. So T1 is 10, D is 3, which means the general term is 10 plus n minus 1 times 3. I'm going to give everybody a minute, literally 60 seconds, to multiply that 3 by the n minus 1 and collect the like terms together to get a simplified form for our answer. In other words, if we take a look at the previous question, I don't want this, I don't want that, I want a nice tidy little package. I want it put together. And 60 seconds is generous, right, at this level. How many of you would do that without even writing an intermediate step there? You would just say, well, it's going to be 3n plus 7. I would just caution you about that, because when you do stuff in your head, for me anyway, if I get on autopilot and I just look at it and do it, sometimes I don't get the numbers right. But if I do expand this, I get the following. And that gives me 3n minus 3. Plus 7. See? Autopilot. Are we okay with getting that? Okay. Now, listen, I want to back away from this question for just a second. I think this concept of a table, I'm not talking your calculator, but the concept of the table on paper is huge in understanding math and relationships between things. If I said to you, what is T12? If I said, what is T12? Well, that means you're going to put 12 here and you're going to find Tn, right? So what comes out of this is the term value. What this question is asking, though, is what number n would you have to use to get 220? Because 220 is the term that we're trying to find out the placement of. In other words, let me explain to you in a different way. If we discover, well, let's try this. Can you put 12 into this equation at the bottom of the page? Just do that for me. You can do it on your calculator. You can do it in your head. I get 42. No, I get 43. I get 43 when I put 12 in here for n. So you could fumble around in the dark and go, maybe the answer is 12. Oh, that's not 220. So you could try a different number. You could do that. But I'm trying to impress on you this idea here in this question. That's what this question is asking you. What value of n will give you 220? And as soon as you see that, it's a grade 5 equation. Well, it's not even a high school equation. I don't know what grade it is. It's a junior high equation, maybe. It's a simple linear equation where you have to subtract 7 and then divide by 3. And I believe you're going to get 71, but. So I subtract 7 from both sides. I divide both sides by 3, and I get 71. And isn't that a lot easier than what we were doing before, where we have to, figure out how many common differences and then add 1 to that? I hesitate in showing this, but I'm going to anyway. I think this is the best way to do this problem. However, we could have solved the problem from here. I could have put in for Tn 220 equals 10 plus n minus 1 times 3 and solve that for n. And to do that, I would subtract 10 from both sides first. Then I would divide both sides by 3. And then I can add 1 to both sides and get 71. However, I think it's better to simplify first and then do your substitution and solving. And I don't really want to get into why, but I think if, generally speaking, if you put in your parameters and then start putting in one of your variables right away, I think it's cause for confusion about what's going on. But that would work as well. Any questions with that example? All right. Algebraically find the number of terms in this sequence, and I'm missing something here. I can tell I'm missing something. Negative 139. I would like everybody to think very carefully about what I'm about to say. This question is asking us to do the exact same thing as the previous question. The previous question is saying which term number is 220, right? Well, this is saying which term number is negative 139. Because if negative 139 is the 17th term, that would be a wild guess. If negative 139 is the 17th term, and it's the last term in the sequence, then there are 17 terms in the sequence. We're asked to do the exact same thing here that we were in the previous question. Tn equals T1 plus n minus 1 times d. I'm not even going to write down what T1 is. You can see what it is. It's 5. I'm not going to write down what d is on the side. I hope you can see that d is negative 4. What this question is ultimately after is the answer to this tabular question. What value of n gives us negative 139? But again, I would prefer if you simplify the equation first before you put in the value of Tn. By the way, do you remember me saying yesterday how important it was that you don't mix up the term number and the term value? This is exactly why. Right? There's a difference between n and Tn. So I'm going to simplify this first. I multiply this out, negative 4n and positive 4, so I get Tn equals 9 minus 4n. This is saying put negative 139 in for Tn. And again, I mean, I know there are teachers out there, I'm not saying at this school, it could be any school, that would just say, well, now you solve this. But I want to talk about the intricacies of solving an equation like this. I don't like that negative 4n. I'm going to kick it off to the other side where it becomes positive 4n. And that means I got to punt the negative 139 out of the way, which means it goes to the other side as well, where it becomes positive. There's actually a word for this in mathematics. It's called transposition. When you take a term on one side and you move it to the other side, we transpose it. So I end up with 4n. And remember what I said, you should be working down equals 148. If you want to work side to side, it's okay to do this. But never go equals, 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 equals left to right. Divide both sides by 4, I get 37. Is that right? 37? Okay. So n is 37. That means there are 37 terms in the sequence. Any questions with that one? right? We've got an arithmetic sequence that's defined by t sub n equals 2n plus 4. Again, what that means is you can put in different values of n and get the term values coming out. And by the way, it's very quick for us to generate the sequence, because if I put 1 in, I hope I don't have to show work here for you. You get 6. If I put 2 in, you get 8. To how many of you does it make sense that it's going up by 2 each time? Why is it going up by 2 each time, Aoki? The common difference is 2. How do you know the common difference is 2? By looking at the equation. Yeah. Is it Charlie? Is it Charlie? Charlie, go ahead.
Because for the simplified version of the equation, the d always mentions times.
A little louder. It's okay.
Because for the simplified equation, we know that the d goes n times in front of the n, so that you would know.
All right. So what you've remembered is from yesterday, the tip that I've told you is that whatever number is in front of n is going to be d. It's always d times n. And the reason why that works is because every time n goes up by 1, you're multiplying by an extra 1 each time. You're multiplying, in this case, by 2, an extra time. So you end up with 2 more. And at this point in time, you don't even need the formula anymore. You can just do that. So we're asked to sketch a graph. Am I correct in saying that these darker lines didn't print out well on your handout? Okay, but you can see that it should be at 5 and 10. So when n is 1, Tn is 6. When n is 2, Tn is 8. Hey, just a second. Is it really necessary to look at those numbers when we construct this graph from here on in? No, because you go over 1, n increases by 1, you get 2 more because the common difference is 2. This is what it looks like. Done. I don't know if anybody remembers this from Math 10C. Does anybody remember these words, continuous and discrete? No? Jay? Turns out no. It isn't about whether it goes on forever or ends. It's about something different. Yeah.
If there's like continuous as if there's the values in between the dots.
Right.
In the graph or in the table.
Right. So if this is continuous, I would be justified, and I'm going to paraphrase what you just said. If this was continuous, I would be justified in drawing a line there and saying that every point on the line is a point in this relationship. Is this continuous? No, because there's a first term and a second term. There's not a 1.85 term and a 2.6255558 term. There's a first term and a second term, etc. So we are not allowed to draw a line, which means it's discrete, because n has to equal 1 or 2 or 3 or 4, etc. I don't really have enough room here, but if you wanted to, you could write in that n can't be any number. N has to be a whole number, or I guess a natural number. I misspoke when I said a whole number. Whole numbers include 0. N cannot be 0. There's no 0th term. But there is a first term. The natural numbers are the counting numbers. Okay, the ones you can count with your fingers. Explain the significance of the graph being linear. Well, you can write this down or not. It's just a point of interest. It's linear because there's a common difference. When you go over 1, you go up 2. Over 1, up 2. Over 1, up 2. The slope of this line is 2. Even though it's not a line, it's just dots. The slope is constant because there's a common difference. And that's one feature of arithmetic sequences. The lines are straight. All right. We have one last example to do. What's going on here? The first term of an arithmetic sequence is 4x. It's not a number. Live with it. It's what it is. The first term is 4x. The common difference is negative 5x. So before we write the general term, let's write out the sequence. The first term is 4x. What would the second term be? Well, the second term is going to be the first term plus the common difference. So what do I get if I take that first term and I add the second term? Well, this is basic algebra. This is grade 8 or 7 algebra. Nevertheless, an explanation might be in order. This is like having $4 and adding negative $5. You get negative $1. You know, the analogy doesn't really work too well with kittens and puppies, but if I had 4 kittens and I added negative 5 kittens, what that means is I've got 4 kittens and I've sold 5 kittens. I'm in the hole by 1 kitten. I have negative 1 kitten, right? I owe somebody a kitten. That's what the negative means. So what this works out to be is negative 1x. Well, what would the next term be? I want to add negative 5x to negative 1x. Well, I get negative 6x. And if you're following along here, I'm pretty much kind of ignoring the x's and saying 4 becomes negative 1 becomes negative 6. It's just that they're x's. So what is the general term? Well, t sub n equals t sub 1 plus n minus 1 times d. Let's load in the parameters that are right here. Now there's a slight difference here. The parameters aren't numbers anymore, but they're still parameters. So I'm going to put in for t1 4x, and for the common difference, negative 5x. Notice that I put that negative 5x in brackets. Again, everybody, you have to do this pair of multiplications in order to proceed. I'm going to get t sub n equals 4x. Let's see, negative 5x times negative 1 is 5x. Negative times negative is positive. Negative 5x times n is negative 5xn. There's nothing I can do with that. That's like saying, what's a times b times c? It's ABC. So what's negative 5x times n? Negative 5xn. These two I can bring together. By the way, just to prove to you that this works, if I put 1 in for n, I have 9x minus 5x, which is 4x. That's the first term. If I put 2 in for n, I'm going to have 9x minus 10x, which is negative 1x, which is t2. It works. So this is the answer to A. B, what's the 12th term? We'll put 12 in for n. I don't know how I can forget things so quickly. Was it 9x minus 5xn? Thank you. So we're just going to put 12 in there. And I've written it this way to impress on you the idea that when you multiply 3 things together, you can multiply 2 of them together and then worry about the third. If I have 2 times 3 times 4, I can go 2 times 3 is 6, times 4 is 24. Or I can go 2 times 4 is 8, times 3 is 24. So I multiply the 5 and the 12, and I get 60x. So T12 equals 9x minus 60x, which I believe is negative 51x. I have it's not really a mistake, but something I probably should have written differently. At this point, as soon as I change this n to 12, this subscript should probably be 12. Right? It's no longer Tn. It is, in fact, now T12. Which term is equal to negative 126x? Well, first of all, again, I think this helps some people. In B, this was the nature of the question in B. N is 12, what's Tn? In C, this is the nature of the question. It's telling you the term value, or the term itself, is negative 126x. What's n equal to? So we take this formula right here, this one, and for Tn we put negative 126x equals 9x minus 5xn. Oh boy. Question for you. How are we expected to find n when there's x's everywhere? Because n is going to be a number, right? If I rearrange this for n, how can I get a number when there's x's there? Any ideas on how we can unpaint ourselves from the corner here? Looks like we painted ourselves into a corner. It looks like we can't get out. No? Yeah.
You're gonna probably try to find some point where you can divide x by x to kind of cancel it.
Right. And in fact, you know what? That point can be now if we want. We are always allowed to perform any operation to both sides of an equation. So I can divide both sides of this equation by x. And when I divide this by x, that's what happens. When I divide this by x, it's wiser to just say I'm going to divide both terms by x. So what happens now, cancel, cancel, cancel. And we are going to have long conversations about when you were allowed to cancel, but today is not the day. Because some students see x and x and they just go, oh, let's cancel. You can cancel here. What are we left with? We are left with maybe not a grade 7 or 6 equation, because of all of the negatives, but it's certainly simpler than Math 20, isn't it? I don't like that negative 5n. I'm going to move it to the other side. The 9 doesn't move. It stays the same. I'm going to add the 126. $27? Thank you. It's the 27th term. This lesson focuses pretty much entirely on this formula. What you've got now is a tool that takes the puzzle solving out of it. It's just an equation. Put in the things and use algebra. By the way, I grew up, and when I was taught this, we used A for T1 as well. And it took me a few years to get used to the fact that it's Tn equals T1 plus n minus 1 times D. We're having a private conversation here because in some school systems, they use A for T1. So what you would be used to seeing is this, right? Yeah. You'll get used to it, just like me. So there's the assignment, a variety of questions. That A, B, C means just for question 7, you can do A and B and C. And I will let you know right now that tomorrow we have a short lesson. We'll spend some time going over problems that you might have, and we're going to have a quiz tomorrow. like a 10-minute quiz on arithmetic sequences. 2 or 3, maybe 4 questions, multiple choice style and numerical response style. So stuff that I don't need to see your work on. Capiche? All right, I think I've left you about 15 minutes here to work on this and get a good start on it. Give me a minute to do a couple of things at my computer, and then I'll be around to help you out.